Hello everyone, my name is Benedict Archie Jr. with student ID 2505110036 and welcome to our conversation about programming with objects, also known as object-oriented programming or simply OOP. Today we have four computer four computer engineering students. I will give them the time to introduce themselves.
Hello, I am Resto Ariasata with student number 2505110043.
Hello, my name is Kimi Komalama with student number 25051100032.
Hello, I'm David with student number 2505110044.
Hello, I'm Haniman Zelina with student number 2505110019.
So, hello everyone.
Hello, Ashi.
Hello.
How are you doing today?
I'm good.
Object-oriented programming. Do you understand Mr. Freddy's lecture about it?
Not sure. I was half asleep during the class.
Not really, but I think it's like trying to bundle basic data types into something called object class.
Well, yeah, that's what I'm also thinking about, but also more like another data type.
Actually, it is. Let's say we want to represent a person, let's say. We cannot just type person A. Instead, we have to define it. And then we declare a variable with that class as the data type.
Oh, is that it? How do we assign the name and age then?
We can either assign them one by one or inlinely with constructor.
What the constructor?
It's like an inline settings. Let's see it. Here's one by one and with constructor.
So, like, we define everything in one line.
Yep. So no more longer redundant lines.
It makes sense now. And then we have that quartet of OOP pillars, abstraction, something called with E, inheritance, and something that starts with P.
Encapsulation and polymorphism.
Yes, that's what I meant.
Well, let's talk about the simple one, inheritance. Think like a template.
I always confuse that with contractors though.
It's a template. Or think like your parent and you. Here, something on person will be copied to student.
I think I understand this to make teacher with something from person we are.
That's nice. So we can share one code to literally anywhere.
Yes, so we have the basic template first, then we can implement the template to other class, and we don't have to actually declare a variable with parent class.
That's actually a good idea. Now, I notice there are public and private tag. What are those?
Oh, I think I know this one. Public means accessible to everyone, and provide means accessible to class member only.
Yes, and there's another one called protect. It's like in between. Why? Because it's public for the class itself and inherits class and private outside the class.
What's the point then?
Well, as it names, limiting how it's being accessed. Take a look.
Yeah, so it's basically a very tight control how function or variables being operated. It's not very useful on low level though, but it's very useful on large project and for maintaining the code. And this method can actually hide things. So when you give other people your code, people will only focus what's important. Others are ignored.
Oh, it is that abstraction?
Yes, abstract. But before that, we have polymorphism. It's like having declaration without the body, or like we have a body but we can override it.
What do you mean? It's like having a soulless body.
Pretty much it. But yeah, and the type for such function is called virtual. Let's take a look. Or we can use pointer.
Wow, we're going deep, but is this the face of OOP?
Yes, as like before, on low level, this basically same as non-OOP stuffs, but this good for distributing and organizing your code.
So, management of codes, that's nice. Now, uh, what about the abstraction?
Yeah, abstract mean not clear as David have already said before. People don't really care about what do you own under the hood. For example, we have study prefer and study flower is for making capitalist or make it too small one. Here, we have a lot of abstraction straight from C++ compiler. Let's take a look on one of overload of transforms in algorithm include file.
Ah, what are those? Those are unreadable for me.
My eyes can't even see such thing. What are even those?
Those are what we are using. We don't really need to understand what's going on. The most important is we can just use it and it works.
Or I'll include file like this.
Well, not exactly. For example, in C lib, stdio.h have less abstraction than C++. And fun fact, something as simple as printing to screen was and is an abstraction, especially in Windows. Why? Because
Hmm.
there's something called syscall, and since Windows is closed source, you can't really see syscall in assembly. So we only rely on pre-made binaries from Microsoft Windows, including macOS, and maybe not for Linux. Linux is open source, and we can see the syscall, but still, it is not mandatory to learn it.
So, basically, we have abstraction everywhere.
Well, yes, even in life, you have inheritance for being your parents' child and share a lot of genetics. You have encapsulation because you belong to someone. You have polymorphism because we all humans literally have the same body template. And abstraction because even though we can learn anatomy, we learn science, etc., we still have a lot of mysteries of our body.
Wow, that's actually a good way to put it.
Indeed. Uh, so we covered class and constructor, inheritance, encapsulation, polymorphism, and abstraction with example.
Well, maybe that's all. The quarter of OOP is not so hard after all.
Yes, it's just sometimes too complex to understand, but still understandable after some time.
Guys, unfortunately, that's all the time we got for today's talk. I know you guys want to say more stuff, but we have other stuff to do. So, yeah, my name is Auchi. Thank you for listening to our conversation. I will see you next time. Goodbye.
Yeah, see you next time.
Bye.
Bye.